Hello, APCSA. Welcome. As we had discussed that if we transition to e-learning day, we're gonna branch off from our Unit 14 that we started, which was on 2D arrays, and we will wait until how much ever longer we can before we get into Unit 14 again. Okay, so I'm hoping that this time that we're away, we can actually use this time to work on two other units, which do not really require you to use an IDE as much. So that's my goal. So hence we're moving on to recursion, which is this particular unit. Okay. So with that, let us look at what is the definition of recursion. So recursion is the computer programming process where a method calls itself. So like I said before, right, you have a method, and typically in order to call that method, you put that call outside that method. And when you put that call statement, the method executes and it moves on with the rest of the program. But what if the call of the method is within that same method, right? That's when it starts looking recursive. So if you look at this image over here, this also does a very good job at explaining a recursive sort of a situation where a person picking up the phone is asking, hello, am I there? Okay, let's move on. So recursion is an important topic with frequent questions on the APCS exam. The APCS examination requires that a student can understand and evaluate recursive methods. However, you do not have to write free response recursive solutions. So you must be able to look at a program and tell what would the output of such a program be? What is the goal of this recursive program? But you yourself do not have to think of a solution using recursion. This makes it a lot easier, okay? So we just need to be able to understand what is this program really solving and what is the output of this program. All right, so let's see. I'm going to skip past the next couple of slides, you guys. This is a pre-recursion assignment, and I'm going to move directly into how, when you have a method called stuck within a method, there obviously is an important need to understand is how is this program even going to end? Okay, so this particular slide talks about BASIC, another programming language. And in this particular program, if you notice, this is going to hint on recursion, but a never-ending recursion. So just briefly explaining what's going on here, you have 100 REM. So you could envision 100 to be the program line number. REM apparently stands for, in BASIC, it stands for adding a comment. And the comment says program that counts integers starting at 0. And then you have k equals 0 at 110, and then moves on to the next line. In 120, you do k equals k plus 1. So obviously the k would store 0, now stores 1 in it. Then you print k. And then it says go to 120. So it's basically telling you go back to line number 120 and do k equals k plus 1. So then k goes to 1 and then print k. Then go to 120. So do you see how this is recursive? Right there, okay? However, it's never ending, okay? Let's try writing a program now that is going to hint towards recursion. So here we have a simple program. It's a class. We have a class variable because it's a static variable outside every method in the class, and it's a variable of the class. That's why it's static, int k equals 0. We have our main, which we are used to seeing, and here is our call to a method called count, okay? So this is that triggering call to count. But if you notice what's happening in count, we do k plus plus. So k is coming from here. K is equal to 0, you do k plus plus. You print k, so it prints the 0. And then right after printing it, it prints a space. And then what happens? It calls count again. K plus plus. K becomes 1. It prints k. Count again. And so on. Will this ever end? This will never end. So how does this program look? In theory, this would continue forever. In reality, it continues until the computer runs out of memory and crashes. Okay, so this is they're showing you a potential outcome that could have happened if you ran this program. It would end by saying Stack Overflow error. So this is recursion without an exit. But this is not how we typically write useful recursive problems, okay? So a useful recursive solution could be something like this. It needs to have an exit or a base case is what we call it. So over here you have another class, the same static class variable called k. You have main, and we have two method calls, count1 and count2. Okay, now in count1, what are they doing? Well, the goal of this program was just to print integers from 1 through 100. And obviously, if you're printing something from 1 through 100, you know that having a for loop is one of the most efficient ways to do it. So they have something called an iterative count, which you guys have seen before, and they're just printing the numbers from 1 through 100. Simple, right? So that was all the call to count1. Now what it's doing, it's creating another solution to the same problem, but the second solution, which is the second method that we have here is count2, uses a recursive solution. So what's happening within count2 is we do k++, so k which was 0 became k++, and we print k. So that means what gets printed here? 1. And then if k is less than or equal to 100, since 1 is less than or equal to 100, you call count2 again. It goes back. So then k becomes 2. It prints 2. And so on. This would continue until, so say imagine count2 is now called, and now k became 99. So from 98 it became 99. It printed the 99. If 99 is less than or equal to 100, called count2 again. Now k becomes 100. Prints the 100. If 100 is less than or equal to 100, this is where it is false. So after printing 100, it doesn't call count2 again, because for count2 to be called, this if statement needs to be true. So really that is where it would stop. So both of these solutions would look exactly the same. This was using the for loop, and this one was using the recursive solution to it. Okay. Very good. Let's move on. So now it says important recursion rule. All recursive methods must have an exit that stops the recursive process. The special case or condition that stops the recursive call is called the base case. Recursion fundamentals. So now here they're showing you another example where you want to count from a starting number like 10 up through 25, or you want it to count from A up through B. Okay, you're passing it two parameters where the first parameter is the smaller number, the second parameter is the bigger number. So you have count 1, A and B, so 10 and 25, and you have a for loop. So obviously if you're counting from 10 to 25, again, a for loop is a useful control structure to be able to do it. You're going to print 10 and then k++, and so on. This is going to print from 10 to 25. Another recursive solution to the same problem is going to look something like this with count2, where you're passing it two values, A and B, and you're checking if A is less than or equal to B, print A. And then you're calling count2 within that if statement, but what will you pass to count2? A plus 1. So that each time when it comes in as 26, since 26 is less than or equal to 40, it prints the 26, and then it's going to call count2 as 27, so that it'll print the 27, 28, and so on. And this will go all the way up through when you do 40 is less than or equal to 40. It will print the 40, and then it'll call count2 as 41. And since 41 is not less than or equal to 40, that was where it'll stop. So you have 26 through 40. So again, they have the same goal. Both of these have the same goal. It's just different ways of writing the program. This is iterative and this is recursive. Okay, now at this particular example, you guys, I'm going to stop. I'm going to take this example on another software to be able to do some working on it, to be able to help you learn how to trace recursion, as well as trying to point out an important difference between two kinds of recursive calls. You have a post-recursive as well as a pre-recursive, and it's important for us to know how they both behave different. So that's it. And this particular video, please go to your next video. See ya!